So in previous lecture, we have seen that already we have discussed about the naive-Bayes classifier algorithm and how it works, and simple how is using the beauty of Bayes theorem, how the naive-Bayes algorithms classifier works. For here, we have taken the K classifier. Okay, that all the theory part, I think all of you are clear. Now we are coming to the our example part. So let's take an example. Just picking here the example that's from a blog that is subtleline.com, and usually if you just type the subtleline.com naive-Bayes classifier, then you can easily find this example. Okay, so let's discuss about what is about this classifier. So simple, in this example the author of this blog had taken the four features here. Simple, the first features is f1 features. Simple, second feature is f2 features, third one is immunity, and fourth is want. Simple, they have the four features, that is outlook, temperature, immunity, humidity and want. So these four features they have taken. Okay, and the features one have simple three classifications, that is three type of features one we have already. That is, first one is sunny, second one is overcast, and third one is rain. So in the first features there are three type of first features, that is, first one is sunny, overcast and rain. Okay, in second features, just temperatures, if you see, also in second features there are three types of second features. The first one is hot, second is mild, and another one is cold. So these kind of features, temperatures. And humidity also, humidity had two types, that is high and normal. Just you can see easily, high and normal. This is the two type of features in immunity. And the wind, if you just see the wind features, in the wind features there have two types as well, just weak and strong. Okay, just see the weak and strong, these two features in the features. So total we have four features, and all the four, and among the first features there have three types, and from the second features we have three types, and from the third features we have two types, and from the fourth features we have only two types. And if you see, this is a simply binary classifier. So our actually in example we have to predict, we are actually, according to the environmental situations, that is outlook, temperatures, humidity and wind, we have to predict the play of these according to our environment. Play is we have to play or not. So it is simply a binary classifier. It is a binary classifier. It is a binary classifier, and we have four features: f1, f2, f3 and f4. Okay, four features, and the h4 features is contains the categorical features. H1 is the categorical features. Okay, I think and the class level is, we have two types, only two type of class labels, that is, or OII is yes or no. Okay, this is the simple. I think you have already understand the problem, what is the problem now, and what is our requirement. We have only here 14 data set is here actually 14, and we have to, for a given point, we have to predict on this day it is possible to play or not. Okay, so just if you just what actually our requirement, what we are want to predict. We, for a given point, suppose if for a required point, suppose for a given point, if our required point is xq. Okay, for a given point xq, okay, we are interested to find its class level, probability of the class level. So where we have the two classes, suppose let's take class level is c. Okay, for class level we are interested to find this probability, that is for xq, and simple it is for f1, f2, f3, f4. This is responsible for what? And for query point we have q1, q2, q3, q4. This is our probability. This is our point, actually point type, and we are interested to find this probability. Okay, so to this we have just if you just remember the naive Bayes probability, what we'll find from this one, and this probability we can be easily written as all features 1, features 2, features 3, features 4. That is for responsible for these points, responsible for this point. This feature is responsible for this point. So simple, instead of again and again writing xq1, just I am simple writing the f1, f2. So just don't think these features are the same as these features. These features means this point is responsible for this point. This features 2 is responsible for this point, that is xq2. These features f3 is responsible for xq3. Similarly for f4. So just remember the naive Bayes theorem. So what is telling the naive Bayes theorem? Naive Bayes simple telling that it is the probability. This is proportional to just simple. This thing is proportional to what? So our conditional probability f1 for c, okay, and to p of f2 given c, p of f3 given c, p of f4 given c. At last we are interested in the probability of c. We have to calculate this term, okay, and we have interest to calculate this term, simple. And on this term we have to calculate it for the two features for output c. Actually what c, just see this one, just I am using another. So if you just see, c is what? C is yes or no. C is yes or no. Actually we have to find this probability of our class level, that is c is yes for a point, for the point xq, and we are interested to find these two probability. And among which is the better, which is the larger, among this we have to find max one and the maximum one, and the maximum one will be the query point. Suppose if your query point is xq, then corresponding output, if is corresponding yq, will be the max one. From that max one, suppose let's take it is the max one, so its class level will be, this point class level will be yes, if this one is the max one, if this one is the max one. So this is actually we are interested to calculate in runtime, in that is test phase, but in training phase now we are interested to calculate this one. Okay, this one means this one, this one, this one, this one, these 5 things we are interested to calculate it in our phase, in training phase. Okay, so let's see one by one. Okay, first just calculate the probability of c. How we will calculate the probability of c? If suppose let's say our c is equals to yes, if c is equals to yes, then how we will calculate this value? So let's count how many we have total 14 data points. We have total 14 data points. Out of 14, how much actually in class? Yes, 1, 2, 3, 4, 5, 6, 7, 8, 9. So out of 14 we have only 9 points are yes. So the class level, that is the probability, that is actually probability of c is equals to yes. So similarly I think you can easily find the probability of c of no. So what what will be the probability? C of no, what will be the probability? So this probability will be simple 14 by 5 by 14, because the rest of the point, actually we have total 14 point, and we have already got that our among these 14 point, only our 9 points are yes, and rest of the 5 points will be no. So our no will be this one, 5 point. Okay, this five pointer will know. So the probability of this, I think this thing is clear, all of you. Okay, now let's say how we will have calculated this thing. This probability actually called the likelihoods probability. Okay, we see this one already we see this one. This probability, this kind of probabilities we call the likelihood probability. Okay, likelihood probability, this thing. So how we will compute it now? This is the main thing. So we can easily count this probability of C by counting simple technique. And now how it calculated this likelihood. So let's see. Okay, what happened? Okay, this is actually the learning phase, and let's take how we calculate it. This one. Okay, let's take. Actually, we have 4 features. So first features is, we have actually 4 features. So first feature is outlook, that is our features 1. Second is temperature, that is features 2. Third is features 3, that is humidity, and fourth one is wind, this is features 4. This is our actually 4 features. And for, let's see how for each features how we will calculate this value. Okay, first if you see the outlook value, so in outlook features we have 3 criteria. Sunny, that is first one is sunny, second is forecast, then third one is rain. We see that in table, we simply see this thing in table. Oh, sorry. You see that this thing, we have only 3 features: sunny, overcast and rain. Sunny, overcast and rain, these 3 features for outlook. And let's see. So first we are and our class level is what? Yes or no. Only we have 2 class level, that is yes or no. Okay, so first see, if you just consider the yes class level, how many points are sunny? So first just see our table. First we are just considering the ES class level, and in ES class level, let's see how many points are sunny. So just we are using here another color too. Okay, just choosing the green color. So class level, no, this one yes. So yes, our class level overcast. Yes, this 3 one is yes. This 3 one it's yes. So among these 3 ones, there have any sunny? No, there have no any sunny. So let's see, it is the yes, here no sunny, it is this one are yes, this one are yes. So let's see in this yes how many one are sunny. Yes, this is sunny, one, this is sunny, only 2 are sunny. Okay, so sunny given class level yes, so 2.2. Let's see from yes how much are overcast. So if you just see the overcast point 1, rain, just see overcast these 2 much. Just overcast how much? Overcast if class level yes. So we see that we have total yes class level how much? We have total class level yes, I think overcast another one we have got forget. Yes, this one total 4, I think total 4 one. Yes, total 4. So overcast is 4. So we see how much we have the ES point 1, 2, 3, 4, 5, 6, 7, 8, 9, and 9 we have already got the 6 point, and so the rain will be what? So the range for class level yes will be among 9 we have already taken 6 points, only rest the 3 points. So just using this simple counting technique we are finding this one, we are finding this table. I think you are already learned how we are calculating this value. Okay, just see here. Just we have considered the sunny, then only 2 points. Consider the overcast, only 4 points, and rain, only 3 points out of total 9 points. Similarly, for no classes, we can easily construct this one. Just omit this thing first. Okay. Why? What happening? Okay, just raise this thing. Okay, so I think you can calculate this one. For no classes also, for no classes you can easily calculate it. So we have only 5 no classes, and only among these 5 classes we have 3 sunny point and 3 rain point. Okay, so just divide, if this is the simple frequency. Okay, this is the simple frequency, and now just we are using simple this frequency, we are interested to calculate a probability. And now how we calculated this probability classes? Simple, we are dividing this value by this one. So we have sunny, and out of total 9 sunny point we have only got 2 sunny point. Out of total yes in yes classes, we are simple just interested to calculate this probability. Means probability of our sample, our outlook features 1 is equals to sunny. With given conditions our class level is equals to yes. Yes, this simple finding these out, these features means our already this is given. Okay, this given means this our 9 point is given, and on this 9 point our feature sunny means 2 points. So simple, just if you just using the conditional probability concept, just we have seen in the first lecture how to calculate the conditional probability, just simply using this concept. Okay, just I am calculated these values. Okay, I think now how this table is calculated you are all about clear. This one, the same thing is calculated for features 2 also, features 3 also, and features 4 also. It's the same thing, the same process we are using of calculating this 4 table. Okay, I think now this one is clear. This thing is clear how we calculated this table 4 features among the 4 features. I think clear all of you. Although if you have till now it is not understand, you are not understanding this thing, please comment below, then I'm just you personally I message you. Okay, so now let's see how we just before of this part I'm just already I am talking how it calculated this value. Probability of C is equals to yes, our probability of C is equals to no. The same thing is used, they are using here. So probability of yes is 9.5 point out of total 14 point. The probability of in this class is 9 by 14 and 5 by 14. Nothing else. Nothing is fancy here. Okay. So now simple in training phase we have to calculate this 5 thing. Actually in training phase we have to calculate this 5 thing. These 5 thing we are calculated in training phase. Means this 5 table is for features 1, features 2, features 3, and for class levels. So if you just see this thing in training phase, what we are doing, just I'm writing summarize this thing. What I mean in training phase, what we are doing. In training phase, we are calculating the likelihood probability. And in second, we are calculating the probability of our class level. Okay, this calculator we are simple, we are using calculating. So how much we are calculating the likelihood means we are calculating likelihood table for features 1, features 2, features 3 as well as features 4. We are calculating this for likelihood, and we have, let's simple, we have C classes, we have D features, and we have C classes. Okay, so how much we have actually time complexity required, so to calculate it the likelihood, so how much time actually it is required, for we are actually calculating the class level is C, and for each features and for each data point, suppose let's take our data point each, suppose let's take our data point is N. Okay, so for likelihood we're calculating the if I for a given class level C, actually we have to pass through the H point. To calculate the likelihood probability we have to pass through the H point, then we are only calculating the features 1 probability. Similarly for features 2, features 3 and features 4, so we are passing through the ND point, order of ND. And simple for features classes also we are going to the order of NC. Okay, as well I am missing one thing, for class C I am passing through H point and also for class level, but for this point, for these calculations, for to likelihood calculations, if you just think for likelihood calculations I am passing through H data point and for H classes. So just see this thing for features 1, let's take, actually for features 1 we have taking the 3 category of features 1, and for features 1 just if you think we have using the 2 classes, yes or no, we have calculated this one. So how much time actually for ES classes, for ES classes we have taking if one features, if we are passing through n number of points, and for these features and these features, so a number of features is C, number is data point is n, so we are just passing, so NC I think. And how much table we have calculated, so for each features we are using ND, time complexity ND, and we have C features, we have such kind of C features, sorry we have such kind of, suppose we have such kind of D features, sorry some mistake, I'm doing some mistake here. Here we have using NC time complexity, we have using NC, and also we have here D features, for D feature H features we are using D table search. So the total time complexity will be here order of NCD, NDC, okay, so order of NDC. I think that training time complexity of likelihood probability you are clear of all these things, how it is coming NDC. And for class level it is time taking is what, similarly for class level here the time complexity will be order of NC. The same thing is applicable, we are passing for each classes C, OI, yes or no, and passing through each data point C, that is n, simple small n, it is C, so we are required NC. So actually the maximum one will be this one, just consider the likelihood function complexity. So the total time complexity actually in training phases we require total time complexity is NDC. Okay, NDC we have required total time complexity. If in some data sets our class level, that is C is very small. In class level number of class level is very small, so this time complexity will simply ND. If C is simple very less, then D, or simple very less in N, then simple this probability is called the, this probability is simple called the ND, our required time is ND actually. So we see how much time, training time complexity we required. So our actually training time complexity is required order of nd. Okay, and now let's see what is the space complexity we actually we have required. Let's see the space complexity also. So we have required, actually we have to store, for we have actually here 4 features. Let's take, we have d features, f2, f3, f4. Let's take, we have d features and we have c classes. Okay, so for we have to actually calculate the age table for features 1, features 2, features 3, features 4. We have to store this d table as well as we have to store this table. So the total, so just see, we have to store the table, this table for classes C. Actually we have 2 classes, y yes or no. So suppose we have 2 classes, that is C number of classes, and this is the for features 1. So for each features we have to store, we need order of C space. For each features we have to require order of C space for each features. Okay, and for each features, if we require order of C phase, we have so d number of features. We have d number of features. We have d number of features. So for total d number of features, actually we have required order of dc number of space. We have required space, actually space complexity is order of dc. Okay, this is the training time complexity and space complexity. Now let's take what we are doing in test phase. Let's see. Oh, sorry. Let's see what we are doing in test phase. So in test phase, actually, just I'm interested to calculate these two values. Example, in test phase, we are interested to calculate these two values, this value and this value. Okay. So to calculate this value, suppose let's take here, they are taken the example. Suppose let's take, we are using our query point is like that. Excuse sample, it is x test. Here they are taken x test, means this point. Means our overlook is sunny. I'm just written this point. Our temperature is cool, our humidity is high, our wind is strong. Okay, this is our query point. Now we have to find the yq. What will be the actually yq? We are interested to find that. So how will you will see how to find that? We have to calculate the first c of yes for this point, and we are calculated the for no for the x dash point. So among these two probability, which one is the maximum? These will be our probability classes. So how to calculate this one? So just simple, just by naive based calculations, we are first multiply the likelihood values. This one likelihood, this likelihood, and the class probability of these things, these 4 likelihood we are already getting from the previous table. Already we have seen. So this value is actually occurred 0.553, and these values similarly for class level no, these value already have taken from our previous tables, and this value we have seen that this value is 0.002. So among these two values, which is the maximum one? So this thing, that is no, this is the maximum one. So this thing is maximum. So what will be our required class here? So simple, our required class will be, so this is the actually our value, and our actual required class will be this one. No means our, if this is maximum, so we can call our probability, if this yq for this point, this class is equals to no. According to this data, we can conclude this one is done. So now the thing is that in training time, after training time, we have to store this value, means this value, this value, this value, this thing we have to store. Now the question is, the main question is how to store this one to easily find. So to sort in order of time, if you just remember Python language, there we are already simple using the dictionary. By simple in Python using simple dictionary. If you just write down this thing in a language, if you just simple using the Python language, simple by using the dictionary. So if you just remember, in dictionary we are using two things, one is key and one is value. Okay, so simple, in key we are using this thing, that is in this thing we are using as key, and it is its value we are taking from the table as value. So you just store this thing in a dictionary structure. Okay, just I am storing this thing, Sani of given class level yes. This thing will be, suppose we got, I think, Sani and yes, how much we will got, just see this thing for Shani, yes, for Shani and yes, this one 2 by 9. Example, we are taking this value 2 by 9. Similarly for Sani, no. Okay, so Sani, no, how much, this value will be key, this value will be Sani, no, 3 by 5. So similarly rain, just rain, yes, this value will be this, yes, 3 by 9. By simple, just using this structure, dictionary structure, if using, then you can easily store this value. And we simple using the order of, in constant time complexity, order of time, one time complexity, you can easily find the value. Okay, I think it is not a hard task to find this value. So simple, just the main thing is calculated this value. So the runtime complexity, so that we see that the training time complexity is order of NDC. Okay, training time complexity and training space complexity is, we see that order of DC. We see this now, the test thing. Now say the test time complexity. In test time complexity, will be what? Order of, actually we have to calculated this one 2 3 4. Okay, we are calculated for 4 features. They have 4 features, we are calculated this one and this thing for each class level. But actually we are interested to calculated this thing for features, likelihood functions into total classes. We are totally, this likelihood means what, how much likelihood. Actually we have, if you have D features, we have calculated this D likelihood values, and if we have C classes, we have calculated these things, C values for H classes. So simple, our time complexity will be DC, and while will be the DC will be actually the time complexity sample, and the space is, we have seen the sample in training time we are using sample or DC time space complexity, and test time complexity will be simple order of 1. Okay, I think it is not a hard task. So if our sample, if we have a D is small, if the features of a data cell is small and C is small, class level is also small, then we can easily build a low latency system. You can see that. And also we have need is simple, we need a very small space complexity. Okay, so if you just finalize this thing about the time complexity and space complexity, so we have concluded naive Bayes is much better in terms of space at runtime, because we see how much low space we have required. If your dn is very small, then it is the totally our space is not a matter. Actually main thing is our data, number of data sets. So here we have not included number of data sets, so this thing is so low. So it is much better for a runtime time complexity, because we see this order is order of dc in naive Bayes. And if you just remember knn how much, so I think it is nd. So how much greater than it is the in simple knn. So I think in space, in comparison with space, so our naive Bayes own instead of knn. So our space complexity for kn is order of n if n is very large in d. In general it will happen, and if you see the data sets, it is generally happen n is very larger than d. So in for knn, for this purpose, for this comparison of space complexity, our naive Bayes algorithm is much better than the knn algorithm. So simple for this reason, simple for this reason, our naive Bayes is memory efficient algorithm. At simple runtime, it is simply memory efficient algorithm. I think all the concept about time complexity, space complexity, why this naive Bayes is better than knn in according to space complexity from this example, and how to calculate it, how to use the simple naive Bayes technique to calculate it, to predict the class level. I think all the concepts from this example are really clear. Okay, although if you have any problem, please comment below. Then I am in my best, I am trying to give your answer as easy as I can do, explained easily. Okay, I think this is enough for this lecture. Okay, bye.